Today, today we start our review process getting ready for next Wednesday's test. A reminder that this test is going to be the test you have the opportunity to score your best on here, especially at the beginning of the semester. This class continues to get more difficult. The second half of this chapter in particular is difficult. Okay, we're splitting it up into two separate tests. You need to do well on this test on Wednesday. Okay, if you do poorly on this first one, you might start yourself in a hole that's going to be a lot harder to dig yourself out of. So make sure we're working through things. Today, we're doing a review over all of that. Our first period, we were a little slow, so we're going to try to get going a little bit quicker, make sure we understand what's going on. Okay, looking at bell work, it says water is removed from a tank at a rate modeled by R of T in liters per hour. So R of T represents water being removed from the tank, and it is a rate. R is differentiable and decreasing. Words like decreasing often are important, so I'm going to go ahead and highlight that as well. Selected values are given. At time equals 0, there are 50,000 liters of water in the tank. Estimate R prime at 2. Show the work that leads to your answer. Interpret what that means. Include units of measure. So we are trying to estimate R prime. What is this a table of? R. So what do I need to do with R to find R prime? Slope. We are finding slope here. They're giving me values. I'm trying to find the derivative of it. I can't take the derivative of numbers, but I can find the slope. Which numbers up here am I going to use if I want to find R prime at 2? 1 and 3. We are doing slope using those two values. So if we set that thing up, it is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We go ahead and subtract. We get negative 240 all over 2, or negative 120. We find the derivative, given a table, finding the slope. What are our units going to be there on negative 120? It was liters per hour. Austin? Wouldn't it be liters per hour, squared? Liters per hour squared. Because again, this top number was liters per hour, and this 2 on bottom was also hours. So it's liters per hour, or liters per hour squared. Okay, that is what we're setting this up as. Interpret what this means. So every time we interpret a derivative, we're always going to use kind of the same Mad Lib. Okay, you start off with what you were given. What is R of T represent here? Yeah, the water in the tank. What is happening to the water? I'm sorry, that's incorrect. That is not the water in the tank. It is the rate of the water in the tank. Sorry. Because that's right here. It says R of T is a rate modeled by that. What is happening to that rate? It is decreasing. The rate of the water in the tank. So what does R of T mean? It's the rate of the water in the tank. What is happening to it? It is decreasing by negative 120. No, by positive 120, because we use the word decreasing. Don't say decreasing in a negative. It's a double negative. That's bad. 120 liters per hour squared. It is decreasing by that. What else do I need to state if I'm talking about a derivative? At t equals 2. It is at some time. Okay, at the end of the second hour, or whatever we're going to describe that as. That is our definition. That is always how we describe a derivative. What were you given? Is it increasing or decreasing? What were the units? Time. I would say at t equals 2. If given the opportunity, I'm always going to do the most basic one, which is at t equals 2. Second one says they use a left Riemann sum. Okay, we're using a left Riemann sum to help explain what's happening here, to estimate the total amount of water removed during that 8 hours. Okay, so we are trying to interpret what this is. The integral from 0 to 8 R of t dt. We are using 4 subintervals. How many numbers do I need to use if I'm doing 4 subintervals? Hey, I got that. I got 5 numbers. That's a good sign. Evan, what is the first interval going to look like? What's the width of the first one? 1. It's 1, because we're going from 0 to 1. And then it's 1 times my height. What height am I going to use if I'm doing LRAM? 1340. So 1 times 1340 plus, we're doing my next one. What's my next one going to look like here, Caden? 2, because my width is 2, times my height, which is going to be 1190. Cool. Then my next one. Slade, what's my next one going to look like? 3, because I'm going from 3 to 6, times my height, 950, the number on the left. And then my last one here. Dylan, what's my last one going to look like? 2 times 740. Make sure you have the plus signs in there. But if you do, that is my answer. I don't have to do anything else with that problem. That is going to get me the full answer there. That right there is the change in water. We integrated the rate. That is an amount right there. That is how much water is removed from 0 till 8. Okay, the next question says, is this an over or an underestimate of the water removed? Talk with your neighbor. I'm sure you haven't gotten to that yet. Talk with your neighbor and decide, is that over or under estimate and why? It is a over estimate. What 2 things are going to tell me that this is an overestimate? Austin? Okay, it's an overestimate because we used LRAM and R of T. Don't just say it, but say R of T is decreasing. We highlighted that at the beginning. I don't memorize that either, but I'm going to draw a picture. Draw a picture that is decreasing and then connect rectangles that attach on the left-hand side. Notice that it is an over approximation. What if I wanted to know how much water is actually in the tank at 8 hours? If I multiply by 1/8, that'll tell me the average amount. So I don't want to find the average amount. I want it, or the average rate. I want to know how much water is actually in the tank at T equals 8. 50,000 is how much was at the start. By integrating this, that tells me the change. So if we take 50,000 minus the change, that will tell me how much water is actually in the tank at 8 hours. Everybody kind of okay with that? We'll continue to hit that a lot, but that's a really, really important calculus concept. All right, today, we're changing gears here a little bit. We are starting to review. Initially, okay, last year at this point, we would have done a stations activity where we would have sat in groups and then adjusted back and forth and done some different activities and talked to new people. I can't really do that. So here's what we're going to do instead. We're basically doing what I like to refer to as Bellwork-a-Palooza. I'm going to put questions on the board. I gave you a paper. You're going to do those with your neighbor. After about 3 or 4 minutes, we'll talk through them and see if we're all on the right track. This is helping you getting ready for next Wednesday's test. Okay, so the first one we're working on here is indefinite integrals. So find the place on your paper that talks about indefinite integrals. There are 3 problems right there. Talk with your neighbor. Figure them out. Go. We are doing indefinite integrals, which is just a fancy way of saying find the antiderivative. Okay, and so before I find the antiderivative, first thing I'm going to do is rewrite it. Aiden H, what could I rewrite this first thing as? Yep, to the 2/3 power. And it's got to be negative, correct? Because it's in the denominator, so we're making it negative as well. The e to the x, fine. Okay, I don't really have to do anything with that. 3 over x, great. That's 3x to the -1 dx. Now we are going to find the antiderivative, which is the whole point of finding an indefinite integral. Okay, we're adding 1 to our exponent, dividing by our new exponent. Okay, so if I'm adding 1 to my exponent, Luke J, what's my new exponent going to be? The 1/3 power, good, because he's adding 1 to -2/3, that gets him 1/3. And then you got to divide by your new exponent. So what's my new leading coefficient going to be? It's 6, because he's dividing by 1/3. That's like multiplying by 3 over 1. That gets him that right there. What is the antiderivative of e to the x going to get me? E to the x, because the derivative e to the x is e to the x. The antiderivative e to the x is e to the x. And then I've got 3x to the -1. I add 1 to my exponent and get x to the 0. And then I divide by 0, and that should set off an alarm in my brain. What do we do when it's 3 over x? It is plus 3, because it's a constant, And then the antiderivative of 1 over x is natural log absolute value of x. Just remember those absolute values. Again, that won't make a whole lot of difference now, but it will later on. Is that it? Plus c, because you don't know if there was a constant or not. It's an indefinite integral, so we go plus c at the end. That's our first one. Second one should be easier. Let's look at the second one. We don't have to do any rewriting. Let's just find the antiderivative. 5 is a constant, so it's going to hang out. Jesse, what comes before sign? Negative cosine. Snapchat, negative Snapchat. Okay, he was at sign. He's going backwards. It's negative cosine x. Then we're taking the antiderivative of negative cosine. Maisie, what's going to come before negative cosine? Negative sine, so it's minus sine x. And then we've got 2 is a constant, so it's going to hang out. What, when you take the derivative of it, is going to get you secant squared? That is tangent. That good? Plus c. It was a integral without bounds, so it is plus c. There is my answer on that one. Indefinite integrals. You got to be good at that. Okay, let's try one more here without me telling you. Solve the differential equation. Solving the differential equation is like saying find the particular solution, which is a fancy way of saying find h of t, which is a fancy way of saying do the antiderivative and figure out what c is. All of those things mean the same thing. Okay? Solve the differential equation. Figure out what h is. Well, I told you h prime, so you better find h. When you find the antiderivative, you're going to have plus c. You plug that in to figure out what c is. You solve from there. Talk with your neighbor. Go. We're finding the antiderivative. So the antiderivative, you add 1 to my exponent, divide by my new exponent. So it's 2t to the fourth. And then it's 5t, and then it's plus c. We plug in then to figure out what c is. So it's 2 times 1 plus 5 times 1 plus c. It's all equal to negative 4. 1 to the fourth power is 1, 2, 5, 7. C is negative 11. So my answer to this question is this equation, but instead of plus c, there's a negative 11 plugged in instead. That is the final answer to that question. Questions on 3. Let's switch gears to what we learned yesterday using series notation. Okay, I'm not giving you multiple choice on this. I want you to kind of think your way through it. So the first one, you're trying to rewrite this as an integral. For the second one, you're rewriting this in limit notation. So you got this limit as n approaches infinity. Guy right here, fill in the blanks. See what you can do. Page. If I'm rewriting this as an integral, show me with your fingers, what's your lower bound going to be? My lower bound is going to be a 2. Rosalind, how do you know that it's going to be a 2? Yep, whatever's added inside those parentheses, that's going to be my lower bound. If there's not anything, it'd be 0, but here it's 2. Show me with your fingers, what's your upper bound going to be? It's 7. Harley, how do you know it's 7? Because 5 when you subtract 7, it's 2. Good. 5 is my width, so if we know we're starting at 2, 2 and 5 gets me 7. And then we need to figure out my equation. Anybody know what the equation is going to be? Awesome. Natural log of x, because this whole guy is plugged into that natural log equation. That is my integral. If we're doing it the other way, so we're doing this exact opposite, okay? We're setting this thing up. First thing I need to have is I'm going to have something cubed, because that's what my function is, times whatever the width is going to be. So my width here is going to be 6, because it goes from negative 2 to 4 over n, because I'm dividing by n amount of rectangles. And then here, we're going lower bound plus the width, and then we throw an I in it because that's what we do, because that's how many rectangles there are. Questions on rewriting those like we did yesterday? It's weird with multiple choice. As long as you got a decent shot, you'll be fine. Okay, that's something the day before the test, that night right before it, or 5 minutes before you take the test, you look at it again. I would tell you the same thing in May, right before we take the AP exam. You look at that real quick. That's one of those last second things I don't necessarily memorize perfectly, but if I look at it, all of a sudden I'll be a lot better off when I see that as a multiple choice question. Derivative of integrals. Remember, this is called the fundamental theorem of calculus. given, or find the derivative given y is equal to that. Talk with your neighbor, find the derivative. Go. Here we go. Let's do it. We are finding the derivative. Okay? The derivative of this guy. So don't lose track of this first part. Sometimes, at least I always have students do this. I'm taking the derivative of everything. So I have to take the derivative of 3x cubed. What is the derivative of 3x cubed? You gonna give me? 9x squared. Don't forget to do that. That's just a normal regular derivative. But then I have to take the derivative of an integral. And to take the derivative of an integral, that's the fundamental theorem of calculus. We could do it the long way where we actually find the antiderivative and plug in, but you don't want to. Use the shortcut instead. What's the first thing you notice as you take this derivative? X is on bottom. We want that x on top. So if I put that x on top, it'd be 2x, and the 4 would go to bottom. If I flip the bounds, what else do I got to do? Make it negative, so it's minus. Then we take the x part. We plug it into our equation. So it's going to be minus the square root of 3. We plug in what we got there, 2x. And then what else do I need to do? Multiply everything by the derivative of what you plugged in. Since I plugged in a 2, I multiply on the outside by 2. You could put that whole thing in parentheses. Now, obviously, you're just multiplying that. But that is my setup, or throw that 2 in front. Questions on finding the derivative of integrals. X has to be on top. You plug it in. Then you multiply by the derivative of the exponent, or derivative of the upper bound. Next one. Here we go. Finding definite integrals. Okay, definite integrals. You have bounds. Remember, all you do, you find the antiderivative, plug in the upper bound, minus plug in the lower bound. Find the two of them. The second one's a little bit funky, but the first one's not too bad. Go. Here we go. We are finding the antiderivative first. X to 3 halves. We're finding the antiderivative. A and B, what's my new exponent going to be? 5 over 2. So what's your new leading coefficient going to be? 2/5. Good. And then I got this guy. I don't particularly like that guy, but I could rewrite it as 2x to the negative 1/2. We're going to find that antiderivative. Michael, what's my new exponent going to be? It was the negative 1/2, so now my new one's going to be x to the 1/2, and then you're going to divide by your new exponent, so it's going to be 4. It's minus 4 because he's dividing by half, which is like multiplying by 2. That is his antiderivative. He is then evaluating that thing from 1 to 4, which is annoying, but you can do it. Okay, we plug it in. It is 2/5 times 4 to the 5 halves minus 4 times 4 to the 1/2 minus sign. That's my upper bound. Now we're going to plug in the lower bound. So when I plug in my lower bound, it's going to look like this. 2/5 times 4 to the 5 halves minus 4 times 1. I plugged in 4. I meant to plug in 1. Times 1 to the 1/2 power. If you wrote that down on your paper, it would be wrong. What did I do wrong? Parentheses. It's minus this whole part. You got to throw that in parentheses. You got to subtract both elements, or otherwise it's wrong. Especially on free response, because you could just leave it like that. If it were free response, I'd leave it. But if you didn't put parentheses, it'd be wrong. Now let's do it. 4 to the 5 halves power. That's like the square root of 4, which is 2. And then 2 to the 5th, which is 32. Times 2 all over 5. 4 square rooted is 2. Times 4 is 8. Then I'm going to go ahead and distribute that negative. So minus 1 to the 5 halves is 1. Times 2/5 is 2/5. 1 to the 1/2 is 1. Times 4 is minus 4. 2 times 32 is 64. What I like to do here is then combine the fractions. So 64/5 minus 2/5 is 62/5. And I'm sorry, this should be plus 4 because it's minus a negative. Negative 8 plus 4 would be negative 4. And if I have negative 4, I'm going to get common denominators and say it's negative 20 over 5. So I get 42/5, or like 8.4. But 42/5, if this were multiple choice, which it probably would be, it'd be 42/5. Yes, sir. If it weren't multiple choice, yeah. Circle that boy right there and be done. Okay, but you got to get to that point if it were multiple choice, and you got to keep working. The next one is a good one, but for sake of time, I'm going to keep going here. Okay, let's try this next one. I'm going to help us out here because, again, we're just running out of time. I hate Wednesdays. Okay? If I'm looking at this first one, we are trying to find the integral. This is f over here. You are trying to find the integral. So what are you looking for on these graphs if you're finding integrals? Area under the curve. This first guy, it's a triangle. It's a base of 2 and a height of 1. But you're cutting that in half. So what is this area right here? It is 1 because it's 2 across 1. 2 times 1 is 2. Cut it in half, it's 1. This thing is a semicircle. To find the area of a semicircle, it would be pi r squared. What's my radius of that circle? 2. So it's 4 pi. Is this area 4 pi? It's 2 pi because it's only half a circle. So this guy right here is 2 pi. This is a triangle. It is 1, 2, 3, 4 across and 2 up. So 4 times 2 is 8. But it's a triangle, so it's half of that. It's 4. Using that information, answer those 3 questions. Talk to each other. Go. On this one, from -4 to 6, I'm finding the area under the curve. Show me with your fingers. There's something with pi. What is the number that is not with pi? Should get 3 minus 2 pi is my answer. Why? Because this is negative because it's below the x-axis. That's 1. This is positive because it's above the x-axis. So -1 plus 4 is 3. This is a minus 2 pi because it's below the x-axis. That's where I'm getting what I got. My next one, it's absolute value. Think about what that means. It's this graph, but it's absolute value. Okay, so it might be a little bit tougher for you to visualize, but it means that your shape is really going to become this. You're not going to have any negatives. So this area, and that area. Okay, so what are you going to do with each of these values? Add them. It's like the positive version. It's 1 plus 2 pi plus 4 or 5 plus 2 pi. My last one, I'm integrating from -4 to 6, f of x. Oh, it's this guy. It's this thing. 3 minus 2 pi. That didn't change. But I've got this plus 2. What is that plus 2 doing to my graph? Shifting it up 2. So if we shift everything up 2, it's like this guy plus an integral from -4 to 6 of 2. What is the area going to be if you go from -4 to 6 of the line 2? It is 20 because it's 10 across because it's going from -4 to 6 and you're moving up 2. So my answer is 23 minus 2 pi. Questions there? We obviously ran out of time. The last question was, hey, do 4 subintervals trapezoidal sums? We haven't done trapezoidal sums in a second. Don't forget how to do that. Okay? That's not something you have to get done, but just you can look at.